Welcome everyone. Through this video, I am going to discuss today some problems of plane. Some problems of a chapter of 3 dimension, that is plane. So, before we start, we should know the basic formulae. So, you know, plane is represented by parallelogram. This plane, this is a parallelogram. We denote plane by parallelogram, so by this symbol. So equation of plane passing through a vector and normal to n vector. So A, it passes through a point capital A and normal to the plane. This one is plane, so normal of the plane is this one, n vector. So for proof, we take a point P r vector within the plane. So AP vector, what is AP vector? Equals to r minus a vector, PV of P minus PV of this. Now AP, this is normal. AP is perpendicular to n. So AP is perpendicular to n. So AP dot n equals to 0. So r minus a dot n vector equals to 0. So this is equation of plane in vector form. R minus a dot n vector equals to 0. So we can write also in this form. So r dot n equals to a dot n. A dot n, this is scalar product. If we consider this as d, then r dot n equals to d vector. So this is equation of plane in scalar product form. So its Cartesian form is obtained by replacing r by xi, yj, zk. So r, that is P, is a point. So r minus a dot n vector equals to 0. R equals to this. So a vector equals to x1i, y1j, z1k. So r dot a, r minus a dot n vector equals to 0. So what is n vector? ai, bj, ck. So a, b, c are d ratios. So what is the formula? R minus a dot n. So we get x minus x1 into a. So a. So a into x minus x1, b into y minus y1, c into z minus z1 equals to 0. So this is very useful formula. Equation of plane passing through x1, y1, z1, and d ratios of the normal is a, b, c. Now we can write it also in this form: ax, by, cz, ax1, by1, cz1, cz1. So considering this as d, so this is first degree equation in xy z. Every first degree equation in xy z represents a plane. So this is one form. So equation of plane. Now a plane is also uniquely determined if its perpendicular distance from origin is given. Origin is given and normal is also given. So n cap, this is Li, Mj, and K. So when it is unit vector, So this is in terms of Li, Mj, Nk. If it is not unit vector, we can also express it by unit vector. So in this case, equation of plane is this length is P, this length is P, this length is P. So R dot n cap equals to P. So this is Lx, My, Nz equals to P. So when LMN are d cosine, then right hand side represents length of perpendicular distance from origin. So this is second form, Lx, My, Nz equals to P. Length of perpendicular distance from origin is P and n cap is Li, Mj, Nk. So these are the two forms of equation of plane. Now we solve a problem of plane application. So this is mixed problem of plane and straight line. We have already discussed in the previous class different form of lines. If the line lies in the plane, then shortest distance between line and plane is these four alternatives. So this is problem of Jeemain. So if the line lies in the plane, so look here our main aim, we can find shortest distance between two lines when they are given in normal form. So this is symmetric form, this is in symmetric form, this is also symmetric form, but lambda is not known. So our main aim will be to find lambda. Now any point on the line is 3 minus 2 minus lambda. 3 minus 2 lambda is a point on the line and it lies in the plane. So it is satisfied by the points. So 2 into 3, 4 into minus 2, 3 into minus lambda equals to 2. So 9 plus 8 minus 2 equals to 3 lambda. So 17 minus 2, so lambda equals to 5. So we are getting lambda equals to 5. So 3 minus 2 lambda. So equation of plane is 2x. So 2x. So right, this one is 2. 2 into 3 minus. So this will be 6. 6. So this is 3 lambda equals to 12. So lambda equals to 4. So make a correction, lambda equals to 4. So now if we get lambda equals to 4, so this one is x minus 3 by 1, y plus 2 by minus 1, z plus 4 by minus 2, and second one is x minus 1 by 12 equals to y by 9 equals to z by 4. So these are two lines. Now we have to find shortest distance between them. So shortest distance. So shortest distance equals to B2 A2 minus A1 dot B1 cross B2 by magnitude of B1 cross B2. So this one is formula of shortest distance. So 3 minus 2 minus 4, and this is 1 0 0. So this is A2 minus A1 vector is 2 minus 2i, 3 minus 1, 2i minus 2j minus 4k. And what is B1 cross B2? B1 cross B2 is ijk. Now 1 minus 1 minus 2, 12, 9, 4. So if we simplify, minus 4 plus 18, minus 4 plus 18. So this is 14i. minus 4 plus 18. So minus j, 4 plus 24, 4 plus 24, this is 28 j, k, so 9 plus 12, 9 plus 12, so 21 k. So we are getting these three. So now we calculate the numerator part. A2 minus A1 dot B1 cross B2. Now 2i minus 2j minus 4k, and this one is 14i minus 28j plus 21k. So 28 plus 56 minus 84. So 84 minus 84 equals to 0. So we get numerator as 0. So what is shortest distance? Shortest distance equals to 0. So shortest distance, no need of calculating this one. So shortest distance is 0. So 0 is possible answer. So first we find lambda, then 1 and 2 we can use Cartesian method also, or this vector. So this is mixed problem of plane and straight line. Now look, problem number 3. ABC is a triangle in the plane with vertices A, B, C. If the medians through A is equally inclined with coordinate axis, then find lambda cube plus mu cube plus 5. So ABC lies in a plane. Coordinate of A 2, 3, 5. Coordinate of B minus 1, 3, 2, and lambda 5 mu. If median through A, median, so it bisects BC, this median, this equals to this. So coordinate of D, so lambda minus 1 by 2, 4 mu plus 2 by 2. So this is coordinate of 2. Now median makes equal angle with coordinate axis. So median through A equally inclined. So D ratios of median. So D ratios is difference of coordinate. 4 minus 3, this is 1, and this is mu plus 2 by 2 minus 5. So if a line makes equal angle with coordinate axis, then we know its D ratio. So cos alpha equals to cos beta equals to cos gamma. So cos square alpha plus cos square alpha plus cos square alpha equals to 1. So cos alpha equals to 1 by root 3. So D ratios of the line, D cosine is this. So if you take the positive one, so this is D ratio, and D cosine 1 by root 3, 1 by root 3, 1 by root 3. So look, D ratios of the median is equal to this. So therefore what we are getting, lambda minus 1 by 2 equals to 1, and 1 equals to 1, this one, mu plus 2 by 2 minus 5 equals to 1. So lambda minus 1 by 2 equals to 3. So lambda equals to 5 is 7. Lambda equals to 7. So here mu plus 2 equals to 6. 2 plus 5, mu plus 2 by 2 equals to 6. So mu equals to 12 minus 2, that is 10. 12 minus 2, that is 10. Now we have to find lambda cube plus mu cube plus 5. So lambda 7 cube plus 10 cube plus 5. So simplify and you get result. So actually this is problem of straight line. Problem of straight line. Now we consider from description problem number 5, 8, 9, 11. They are of same type. So main idea is intersection of plane and line. So how it is obtained? A line intersection of plane and line. So we consider a problem first. So problem number 9. A line with positive direction cosine through P and makes equal angles with coordinate axis. The line meets the plane at Q. Then length of PQ equals to this. So the line is not given. So our first aim is to find equation of line through P, and T cosines are makes equal angle with coordinate axis. We have already solved this problem, that is this part, equal angle with coordinate axis. So alpha equals to beta equals to gamma. So we have already proved it. Cos alpha, cos beta, cos gamma equals to 1 by root 3. So what is equation of the line? So equation of the line is x minus 2 by y plus 1 by z minus 2 by 2 minus 1 this, and this is 1, this is 1, this is 1. So 1 by root 3, so root 3 is cancelled out. So this is equation of line. Now we have to find intersection of this line and plane. So how to find intersection of plane and line? So this one is very simple. You look, we consider this as lambda. So this as lambda. So any point of the line is lambda plus 2. So y equals to lambda minus 1 and z equals to lambda plus 2. So any point on the line is this. So if this point lies in the plane, then put value of x, y, z to the equation of plane. So putting value of x, y, z to the equation of plane, we get, so 2 into lambda plus 2, lambda minus 1, and this is lambda plus 2 equals to 9. So 4 lambda, this implies 4 lambda. So 2 lambda, lambda, lambda. This is 4 plus 6. 4 plus 2, 6 minus 5. So this is 5. So 9 minus 5 equals to 9 minus 5. So lambda equals to 1. So putting values of lambda, we get coordinate of point of intersection Q. So what is coordinate of Q? So put value of lambda. So what is x? X equals to 3, y equals to 0, and z equals to 3. So point Q is 3, 0, 3. So this is point Q. And what is point P? P is 2 minus 1, 2. Now we need the length of PQ. So distance between 2 points. Distance between 2 points. So if we calculate 3 minus 2 whole square plus 1 square plus 1 square. So this is root 3. So problems of 3 dimensions are simple. So look, these are all problem of competitive exam. So how to find distance between plane and line? Now we consider similar like problem 11. So these are mixed problem of plane and straight line. The distance of the point 1 minus 5, 9 from the plane this, measure parallel to this line. Measure parallel to this line. So x by 1, y by 1, z by 1. So we have to find equation of line parallel to it and passing through 1 minus 5, 9. So passing through 1 minus 5, so this one is 1. So equation of line through 1 minus 5, 9 and parallel to 1. So x minus 1, y plus 5, z minus 9. So since two lines are parallel, therefore their d ratios are proportional. So this one is 1, this is 1, this is 1. So line is not given directly. So this is the line. Then same procedure as of earlier. So this equals to lambda, suppose this is 2. So x equals to lambda plus 1, y equals to lambda minus 5, z equals to lambda plus 9. Then exactly same. So put value of x, y, z to the equation of length. X plus y, x minus y plus z equals to 5. So what is x? Lambda plus 1. Y is lambda minus 5. Lambda plus 9 equals to 5. So lambda lambda cancel. So lambda 9 plus 5, 14, 15. Lambda plus 15. Lambda plus 15 equals to 5. So lambda equals to minus 10. So if we get lambda, then coordinate. So intersection of line and plane. So coordinate of intersection of line and plane. So if we consider this as q, so this is minus 9, this is minus 15, and this is minus 1, minus 10, minus 5. So one point is fixed, that is P, 1 minus 5, 9. So Q, minus 9, minus 15, and this is minus 1. So what is PQ? Look, root over 10 square, 1 plus 9. This is also 10 square. This is also 10 square. So root over 300. So 3 root 10. 3 root 10. So these are problems 1, 5, 9, 11. Problem of intersection of a plane and line. Now we consider different type of problem from description. Problem number 16, 17, 18, 19, 20. They are of same problem. So angle between plane and a line. So line r dot n equals to d. This is plane, and r vector equals to a plus lambda b. This is plane. So angle between plane and line. So angle between plane and line. So this is plane. Suppose this one is line. So this is the angle between plane and line. So angle between plane and line. Angle between plane and line. Suppose this one is line. So this one is theta. This is line L. And this is plane pi. So angle between plane and line, actually figure is like that. This one is theta. This one is theta. But we are interested to find angle between normal of the plane and the line. So normal of the plane is this. So suppose this one is normal, n vector. So angle between normal and the line is 90 minus theta. So this is our working tool. Angle between plane and line is theta. Therefore angle between normal of the plane and line, this is b vector parallel to b, that is angle between n and b is 90 minus theta. So what is our working tool? Cos 90 minus theta from dot product b dot n by b dot n by magnitude of b, magnitude of n. That is sin theta equals to b dot n by magnitude of b, magnitude of n. So this is our working tool, sin theta, not cos theta, because theta is the angle between the plane and line. Normal of the plane and line is 90 minus theta. So b dot n by this. If angle is sin theta 0, that is theta 0, in this case plane and line are parallel. If plane and line are parallel, then sin theta equals to 0, implies b dot n equals to 0. This is condition that plane and line are parallel. So this will be our working tool. Now in case of Cartesian coordinate, so this is dot product of this, we get corresponding Cartesian formula. So problem number 16 to 20, they are of same type. So the plane 2x minus 3y plus 6z equals to 11 makes an angle sin inverse alpha with x-axis. The value of alpha is given by this. So 2x minus 3y plus 6z equals to 11. So what is d ratios? 2 minus 3, 6. So n vector is 2y minus 3z plus 6k. Now it makes an angle sin inverse alpha with x-axis. So d ratios of x-axis is 1, 0, 0. D ratio, d cosine same. So d ratios of the line, that is b vector, equals to only I cap. So what is the angle? Sin theta equals to b dot n by magnitude of b, magnitude of n. So b dot n, so 2 into I dot I, that is 2 by root over 2 square, 3 square, 6 square. Actually this is minus 3 square, so 2 by 7. So what is theta? Sin inverse 2 by 7. Now according to our problem, the angle is sin inverse alpha. So sin inverse alpha. So if we compare, alpha equals to 2 by 7. So angle between plane and line. Line is x-axis. B vector equals to I. N vector equals to this. Very simple. Now consider problem number 20. So angle between plane and line. Let L be the line of intersection of the planes x plus 3y plus z equals to 1 and this, and L be a line of intersection of the planes this, and L makes an angle alpha with x-axis. So look, so this is angle between two lines. So the line L and x-axis, but L is not given directly. It is intersection of two planes. We have already discussed in previous class also how to find symmetric form of line if two intersecting planes are given. So these are two planes and we have to find equation of line. But here only d ratios of the line, if we know, then our problem will be solved, because we need angle. So for angle, d ratios are sufficient. So our main aim will be to find d ratios of the line obtained by intersection of these two planes. So let A, B, C be d ratios of L. So two planes intersect at a line. This line is perpendicular to both the planes. So d ratios of this plane is d ratios of 2x plus 3y plus z equals to 1 are 2, 3, 1. And d ratios of x plus 3y plus 2z equals to 2. This is 1, 3, 2. So line and normal of the plane are perpendicular. So what we are getting? First condition is 2a plus 3b plus c equals to 0. 2 into a, 3 into b, 1 into c. So this is suppose our equation number 1. And d ratios of second plane. So we get a plus 3b plus 2c equals to 0. So if we solve these two equations, so a by 6 minus 3, that is a by 3, b by 1 minus 4, this is minus 3, c by 6 minus 3 is 3. So a by 1, b by minus 1, c by 1. So d ratios of line, d ratios of L, 1 minus 1, 1. And we have to find angle between L and x-axis. So d ratios of x-axis, 1, 0, 0. Now this is not angle between plane, angle between two lines, angle between two lines. So formula is cos theta equals to a1 a2 b1 b2 c1 c2 by root over a1 square b1 square c1 square a2 square b2 square c2 square. This is angle between two straight lines. So put the values. So 1 into 1 only at the numerator. This is root over 1 square 1 square 1 square, and this is 1 square. So 1 by 3. Theta equals to cos inverse 1 by root 3. 1 by root 3. So angle between intersection of two planes and x-axis is cos inverse 1 by root 3. Now we consider a different type of problem. So problem number 10 and 15, they are of same type. So we need length of perpendicular distance from a point to a plane. So x1, y1, z1. This is P, length of perpendicular distance. This plane is ax plus by plus cz plus d equals to 0. So similar like that of straight line. So length of perpendicular distance. So ax1 by1 cz1 plus d by root over a square plus b square plus c square modulus. So this will be our working tool. In case of straight line, ax1 plus by1 by root over a square plus b square in 2 dimensions. But in case of 3 dimension, perpendicular distance from any point to a plane. So this is our working tool. So also we need idea of equation of plane in intercept form. So x-axis, y-axis, z-axis. So if A, B, C, this is A, 0, 0, OA, x-intercept. So equation of plane x by A, y by B, z by C equals to 1. So equation of plane in intercept form. So these two ideas are required for solving this problem. So very simple. Look. Oh, look, a variable plane is at a constant distance 3 units from origin and cuts the coordinate axis at ABC. So let equation of plane x by A, y by B, z by C equals to 1. So x-axis. So this is A0, 0. This is 0, B0. Y-axis. This is Z-axis, 0, 0, C. So It cuts the plane coordinate axis at ABC. So this is equation of plane. It is at a constant distance 3 unit from origin. So perpendicular distance from 0, 0, 0 to plane 1. So it is given, it is 3. So 3 equals to mod of 1 by A into 0, 1 by B into 0, 1 by C into 0, minus 1 by root over 1 by A square, 1 by B square, 1 by C square. So this is formula of perpendicular distance. So this is minus. So if we take reciprocal, so 1 by A square, 1 by B square, 1 by C square. This root over equals to 1 by 3, or 1 by A square, 1 by B square, 1 by C square equals to 1 by 9. So this is our equation number 2. Now we have to find locus of the centroid of the triangle ABC. So G XYZ be the centroid. Let G XYZ be the centroid of the triangle. So centroid of the triangle is GXYZ. So centroid X equals to sum of abscissa by 3. So what is A? A equals to 3x. So Y equals to B by 3. That is B equals to 3y. Z equals to C by 3. So C equals to 3z. So putting value of XYZ into, so 2 implies 1 by 9x square, 1 by 9y square, 1 by 9. So 1 by x square, 1 by y square, 1 by z square equals to. So this is locus of the centroid of the triangle. So this is most important problem for board also. Now we consider problem numbers 13 and 14. They are of same type. So equation of plane passing through intersection of these two planes. So what are the planes? This one. So transfer all term to left hand side. Minus 3 equals to 0. So what is equation of plane? Intersection of this and this. So equation of plane through intersection of this and this is first equation plus lambda into second equation. So x common 1 plus lambda, y common 2 plus lambda, x minus y. So 2 minus lambda, z common 3 plus lambda. So minus 2 plus 3 lambda equals to 0. So this is 1. So this is equation of plane, first plane plus k into second plane. Now we get lambda by different conditions. Sometimes it is given, it passes through a given point. So put value of xyz, you get lambda. Sometimes it is given that this plane is perpendicular to other plane or parallel to other line, and here it is given it is at a distance 2 by root 3 from 3, 1, minus 1. So given condition 2 by root 3 equals to mod of 1 plus lambda whole square, 2 minus lambda whole square, 3 plus lambda whole square with root over. So a square plus b square plus c square, and from 3, 1, 1. So 1, 3 into x is replaced by 3, 1, y is replaced by 1, z is replaced by minus 1, constant unchanged, minus 2, minus 3 lambda. So total mod. So 2 by root 3 equals to. So 3 lambda minus lambda. So 3 lambda minus lambda minus again lambda minus 3 lambda. So 3 lambda cancel. So 3 plus 2, 5. 5 minus 3 is 2. So this is 0, I think. So 3 plus 2 minus 3 minus 2. So this part is 0. And this is lambda square plus 2 lambda plus 1. Lambda square minus 4 lambda plus 4. Lambda square plus 6 lambda plus 9. So squaring this equation and solving, we get lambda. Putting values of lambda, we get equation of plane. So you simplify this part. So simplification is so 4 by 3 equals to 4 by 3 equals to. So what we are getting? Minus 2 lambda. Minus 2 lambda. That is 4 lambda square. 4 lambda square is lambda square, lambda square, lambda square. 3 lambda square. 2 lambda plus 6 lambda. 8 lambda minus 4 lambda. So plus 4 lambda. 1 plus 4, 5. 5, 9, 14. 14. So 12 lambda square. 12 lambda square equals to 12 lambda square plus 16 lambda plus 56. 12 lambda square. 12 lambda square plus 16 lambda plus 56. So what is lambda? Lambda equals to minus 56 by 16. This is 4. 13 minus 13 by 4. So putting value of lambda, you get equation of lambda. So you solve rest of the problems. So if you solve this problem, I think it will be very simple to score 4 marks from 3D. And it is also, these problems also very important for board exam also. So you try to solve rest of the problem.